Hello class, welcome back to my lair. It's kind of nice down here. Very, very quiet and very peaceful. It's kind of nice too. It's like 65 degrees year round, never changes. It's pretty nice. Anyway, let's get back to some math here. We're in 12-2 today. Where we're going to look at some trig functions of acute angles. We're entering a section that it basically is triangle trigonometry. So triangle trigonometry is has some unique principles that we're going to go over some of those today in this lesson. So again, this is mostly review for a good portion of you, I'm sure, but we're just going to define some things such as the sine of theta. Okay, the sine of an angle is y over the radius. Okay, so we can write that y over r, and very useful. We'll use that a lot. Also, we've got cosine theta, and that of course is x over the radius. Oops. And of course, our friend tangent. Tangent of theta, which is y over x. Okay, so you may be familiar with the phrase SOHCAHTOA, and that's basically what we have here. So, opposite over hypotenuse, hypotenuse of a triangle, that gives us the radius. This radius, we call it radius here because we have a triangle with the initial side here in the standard position, and then we have the terminal side right up here, which forms an angle and gives us this triangle here, but they're interchangeable. Again, so cosine, adjacent over hypotenuse, x over r, and then we have the tangent, which is y over x. TOA, opposite over adjacent to this angle. Okay, so SOHCAHTOA is a good mnemonic for remembering these right here. Okay, some more functions we're going to be looking at are basically the reciprocals of these. So the reciprocal of sine, we're going to have cosecant of theta, which is r over y, which is hypotenuse over an opposite. And then we've got secant of theta, which is the reciprocal of the cosine. So it's r over the x, or the adjacent angle, the adjacent side, adjacent to the angle. And then we have, of course, cotangent of theta, which is the reciprocal of the tangent function, x over y. Now, depending on what situation you're using, which side you're looking for, which angle you're looking for, each of these serves a purpose, okay? And they can make your life a lot easier if you use the correct one. Okay, so let's get into some problem solving using these functions and acute angles and triangle trigonometry. Okay, class, first off, let's look at some of the more standard angles and the values that they give us. These are very useful because a lot of triangles are in a standard formation, either a 30-degree, 45-degree, or 60-degree angle. And those you really need to commit to memory. You don't have to, but they can make your life a lot easier. You can, if you can say them from memory, then you can solve problems much more quickly. So let's just show some of these standard angles. Suppose theta is 30 degrees. 30-degree angle. Okay, so we need to know the sine, which is y over r, sine theta, y over r. That's going to yield a value of 1/2. Okay, so what does that mean? That means that the ratio of this distance here is 1/2 of the radius, or the hypotenuse. It's 1/2 that length. Okay, cosine of 30 I guess we can write 30 degrees here, since we're using the standard angle, is, of course, x over r, or you may remember it as adjacent over hypotenuse, the adjacent angle over the hypotenuse of the triangle. And we write x over r here in our configuration. That's going to equal square root of 3 over 2. Let's make a better 3 there. Square root of 3 over 2. Okay, so this ratio here, from here to there, is square root of 3 over 2, x over r. Now let's take a look at the tangent. The tangent of a 30-degree angle is, of course, y over x, and that is square root of 3 over 3. So just knowing these values when you're dealing with a 30-degree angle, that can save you a lot of time. Another thing to keep in mind, we know the interior angles of a triangle equal 180, okay? So, and here we're dealing with right triangles exclusively. Every triangle we do in this section, we're going to have a right triangle. So we know that one of them is 90, so the other two have to add up to 90 as well. So if I have a 30-degree angle there, I have a 60-degree angle there. That can help you a lot when you're trying to solve these problems. Okay, for the rest of the standard triangles, just take a look at the table. It's in your book. It's a blue box of knowledge on page 558. It's got the 30-degree angle, the 45-degree angle, and the 60-degree angle with their standard values. And look at that table, memorize it if you haven't got it memorized already. Okay, now let's start getting into some of these problems, which are really kind of fun. I like them. So let's go with that. Okay, so let's take a look at number 24. Let's start putting some of this good information to use and seeing how we can use it to solve triangles. Okay, so here's a diagram that they've given me for 24 and its associated problems. And they've given me this information here. I know that A is 3 and C is 6. Okay, small letters. Small letters represent side lengths. Side lengths. Capital letters are usually at an angle, and they are the angle measures. Okay, so A is the angle measure right here. C is the angle measure here, which of course is 90 degrees since we're working with right triangles here. And B is this angle measure right there. Okay, so this is all the information I have. And I need to find out all the angles, and all the side lengths. All right, seems like a daunting task, but armed with our knowledge of trigonometry, not hard at all. Let's do this. Okay, first off, let's find side length B. Side length B we can find using Pythagorean theorem. So I know that c squared minus a squared is equal to b squared. Okay, from our friend Pythagoras. I'll write it this way just in case you need to see that. Solving for b squared gives us this. All right, so let's take a look at this. B squared equal to 6 squared, which is 36, minus a squared, which is 9. Okay, so b squared is equal to 27. And then I'm going to square root both sides, take the square root of both sides. And of course, we're working with positive numbers here because you can't have a negative side length for a triangle. So b is equal to square root of 27, which is 3 square root of 3. Okay, so I've solved for b. So I've got side length A, which is 3, side length C, which is 6, and now I know b, which is 3 square root of 3. Okay, so now I've got to try to figure out these angles here. Let's see, let's find us a trick we can use. All right, take a look at the ratio between A and C right here. So I know that the sine of A is equal to A over C, which is the y distance over the radius, or if I was thinking SOHCAHTOA, opposite over hypotenuse. So either way, whichever way you want to wrap your mind around it. And in this case, I have 3 over 6, which of course simplifies to 1/2. Okay, now thinking back to those standard angled triangles that I need to know the information from, it's in that table on page 558. I know that the sine of A equals 1/2 when A is equal to 30 degrees. Okay, so now that I know that, the rest is child's play. So I know A is 30. I know that C, of course, is 90 because it's the right angle of my triangle. And I can also know that the A and B are complementary. So that says that A plus B has to equal 90. And so 90 minus 30, of course, is going to give me a 60-degree angle, which is B. So B is 60 degrees, C we know to be 90, and A is equal to 30. So we have solved this triangle, just given 2 side lengths. All right, looks good. Let's try some more of these. All right, class, let's take a look at this number 27. I love these kind of problems because they're like a puzzle, and they're all basically the same. What you end up with in problems like this is initially they will give you enough information so that you can solve it, but just enough. So you have to be able to take what information they give you and apply what we know to be true about trig functions and come up with the solution for this kind of problem. And I guess I like them because they're a puzzle, and I really like puzzles. So let's take a look at this one. First off, let's take a look at just this triangle here. Oh, I'm sorry. Overall, we're looking for this value x. Find x. Okay, so let's just initially look at this triangle right here. This triangle. This is a right triangle with a angle of 30 degrees right here. And of course, this is a right triangle. And so, yeah, I know that's 60, but that's kind of irrelevant right now. So if I'm going to try to find this, I'm going to find these 2 lengths. Let's call this one A, and let's call this one B. So once I find A and B, I'm going to know what x is because I can just add up A and B. All right, so first off, let's find A. Okay, so with A, I know the radius or hypotenuse, and I know the angle, and I'm looking for A. So think to yourself, okay, what function do I use to involve the hypotenuse and the x length? So I'm going to be using the cosine function. I'm going to look at the cosine. I know the cosine of any angle is equal to x value over the radius or the hypotenuse. In this case, well, we'll call it radius. And then for my configuration, I have the cosine of 30 degrees, which x is, of course, A in this case, and the radius or hypotenuse is 12. Okay, but I know the cosine of 30 degrees because I've been studying that table and I have this memorized. So the cosine of 30 degrees is, of course, square root of 3 over 2. And knowing that will save you a lot of time instead of having to reference the book a lot. All right, so we can solve for A here by cross multiplying. So 2A times 12 square root of 3 gives me a 12 square root of 3. And solving for A, divide both sides by 2. And that yields A is equal to 6 rad 3. Okay, so I know A, 6 rad 3. Now I just need to solve for B. Okay, So I need to find this length, or this length is my goal, but notice this is a 45-degree angle. A 45-degree angle plus a 90, I know that this is 45 as well. And so if I find this length, I've also found this length. Okay, so let's take a look at this and see how we're going to solve for this right here. Let's call this the height of this triangle. And so we're still looking at this triangle here in blue, and we'll use it to solve for h. Okay, so what angle, or what function rather, would I use to solve for h? I can use, since I know the x length and I know the radius, solving for this, I can use either tangent or sine. Either one will give me the information I'm looking for. Let's go ahead and use, let's use tangent, okay? So the tangent of theta is equal to y over x. And in our case, we have tangent of 30 and is equal to y, which we've called h, over this x distance, which we've solved out already, 6 root 3. So h over 6 root 3 is tangent of 30. But wait, I know what the tangent of 30 degrees is. The tangent of 30 degrees is, say it with me, square root of 3 over 3. Okay, so I can use that information, solve for h. Once again, cross multiplying, 3h is equal to 6 times square root of 3 times square root of 3. All right, so solve this out. 3h is equal to 6 times 3, which is 18. H is equal to 6. Okay, that's good information. So now that I have that, it's a simple matter of looking at this triangle right here. Okay, so I know that this is 6. H is equal to 6. Okay, and this being a 45-degree triangle, 45, 45, 90, that means these two sides are the same length. So it's a simple matter now of putting in this value here. Now that I'm looking at this triangle, adding up these two lengths, and that gives me 6 plus 6 radical 3. And that is x. Okay, so there you have it. Number 27, solved using trig functions. Okay, let's look at one more of these because they're so much fun. Love the puzzles. The puzzle to solve. This is number 29. These are fun. Okay, so let's solve this. This is all the information I have. I've got two triangles that are right next to each other. They form a right angle here. Each of these is 30 degrees. This length is x, and this length is 18. I'm looking for x. I'm trying to find out what this length is right there. So let's attack this thing with a kind of a, we're going to look at in a small view, and then we're going to look at a larger view. And we can see we've got a couple of triangles here. Okay, so let's take this guy right here, and just looking at this, let's put this into a standard configuration so that we can feel more comfortable using our trig functions. So if I put this into a standard initial standard position, I can see what's going on here a little bit better. And I know this value here is 18, and this angle is 30. Okay, so what I want to do here is I want to find out how high this triangle is. If I have the height, and then I can do some other things, I should be able to solve for x. So let's look at this. If I pull this triangle out, stick it here, I can look at finding out this height right here, which is this right here. Let's go ahead and call this h, just for ease of solving. We'll call that h. That's the height of this triangle. Yeah, perhaps that's not a good thing to do because we sometimes call this hypotenuse. So let's not do that. Got to be careful of those kind of things. Let's just call it a. This is just the a length that we're going to use to solve this thing. Okay, so thinking to myself, what function, which trig function involves the height and the length of a triangle that doesn't consider the radius or the hypotenuse? Well, I would think tangent normally, but I'm going to use cotangent, and I'll show you why here in just one second. Cotangent is, of course, x over y. In our case, we have cotangent of 30, which is x, which is a, over y, which is 18. Okay, and thinking back, and I also know that the cotangent of 30 degrees, let's think, tangent of 30 degrees is square root of 3 over 3. Cotangent is the reciprocal of that, so it's going to be 3 over square root of 3. Instead of square root of 3 over 3, it's 3 over square root of 3. Okay, I know, not standard form, but that's okay for now because I'm using it. I'm not using it for an answer. All right, so solving for a. A times square root of 3 is equal to 3 times 18, which is 54. All right, so now solving for a is equal to 54 divided by square root of 3. But let's pretty this up a little bit and put it into standard form. So let's go square root of 3 over square root of 3 so that we can make this look better. All right, so we're rationalizing the denominator, by the way, that's what we call this. So this gives me 54 square root of 3 divided by, of course, square root of 3 times square root of 3 is 3. A little bit of algebra here, divide by 3 on top and bottom, and that will give me 18 root 3. Okay, so now I know the value of a, which is 18 root 3. Okay, so now we're done with this little triangle here. I've gotten my a value. Now let's look at this thing in a little bit different light. Let's look at it as this big triangle right here. Okay, so now I've got this large triangle. I have one side length, and I have an x that I'm looking for down here, which involves a length down here. So notice up here I've got 30 degrees plus 30 degrees. That gives me, of course, 60. If this is 60 total, and this is 90, guess what that's got to be? Yep, 90 minus 60, 30 degrees. This is a standard 30, 60, 90 triangle. That's nice. Okay, so I want a function that involves the height or y value and the length or the x value. So let's go for tangent. Let's do tangent here. So the tangent of an angle is y over x. Make a little bit of room here so we can work this thing out. All right, so let's just continue up here. All right, so in my case, I've got the tangent of 30 degrees is equal to y value, which is, of course, right here, this value that I've already solved for, 18 root 3 divided by this length right here, which is 18 plus x. Okay, another thing I know is, of course, the tangent of 30 degrees is square root of 3 over 3. Now it's just a simple matter of solving for x, which this is Algebra 1 problem here. Cross multiply gives me 54 square root of 3 is that. Multiply this is equal to root 3 times quantity 18 plus x. Okay, so now notice here I've got two entities and they're both multiplied by square root of 3. Let's get rid of the square root of 3's on both sides, shall we? Square root of 3, square root of 3, gone. I can do that because it's all multiplied together. If there was addition in here, I couldn't do that, but I can, so I'm going to do that. 54 is equal to 18 plus x, and so that gives me an x value, which is equal to 54 minus 18, and we know that to be 36. All right, so my x value is 36. That's nice, because now I know the answer. Okay, so we've solved this. Let's look at the steps that we used. We took this inner triangle and we did some stuff with it and solved for this a value here, which gave us the length of this larger triangle. We can use that to solve for another portion there. All right, so love these little puzzles. They're so fun because they give you just enough information that you can use that information and add it to the trig functions, which we need to know, and solve for the unknowns. All right, I'm going to give you a bunch of example problems that you can take a look at and have a lot of fun with this section. I really enjoy these. Let me know if you need any help. I'll be glad to help you. Take care.